this is very important. We go a bit slow. Okay, this one you should know lah. Very rarely they ask you lah. Reasonable volatile at 20 degrees. Very important. If they have to dig you, they'll dig volatility 20%. Because this one, diflouromethoxy will come in. Because if it's too volatile, you need a special vaporizer. Diflouromethoxy will come in. Soda lime is a favorite question. It's potent. What is the significance of potency? Some say, oh, potent. What does potency mean? What does potency mean? Potency means you've got a lot of space to give more oxygen. Right? See, you look at it differently. We look at things differently now. Potent is strong. Hey, but then to me, when it's strong, I got more space for oxygen, which means for a very sick patient, I need to have something very potent so that I can have more space for oxygen. It's very different thinking. They would dig and dig and dig. Low blood gas, rapid reduction recovery, must not enter gases cavity, no metabolite possible. Many things like that. See, ideal. When it asks you about ideal, again, same. What is the ideal property? Physical, pharmacokinetic, pharmacodynamic. Again, everything pharmacokinetic, pharmacodynamic. But theories, this one don't underestimate. The fundamentalists will dig. Fundamentalists will dig. And I've seen people dig until the eyes change color. See, Meyer-Overton. Potency related to lipid solubility. They thought it was membrane disruption of the membrane. Outdated already lah. Outdated. Why? Because sometimes certain drugs also disrupt the membrane, but don't have effect also. Critical volume, which is an expansion of this. Because the fat will go into the cell membrane, expand it, and block the sodium channel. Cannot work. Well, this one, they feel that if you disrupt the membrane, you will have anesthesia. Very general term, disrupt. And then this one is a membrane protein theory. The targets are actually the hydrophobic sites. It is the protein that is the channel, receptors, enzyme that actually cause if you disrupt this, it's actually cause anesthesia, nothing to do with the fat. Then you got the multi-site. Correct lah. Everything you don't know, you simply blame everybody lah. Multi-site, don't know, blame everybody lah. Different inhalation agent alter the different function and different concentration. You give this low concentration, you get this high concentration, you get this. So probably this is the most effect. So now what does this? I guess this one we say already. See? Ligand gated. Now proposed. GABA and NMDA voltage are now proposed the main side action. See, GABA. We must be anti-GABA. This is why we must be pro this, pro GABA, anti this. Stimulation of the inhibitory, suppression of excitatory, and it is excitatory will give anesthesia. That's the basis. This is the whole basis. We must pro this. Stimulate, anti this, suppress this. That's it. So when you read this at this channel, the agent is an agonist. When we are pro, this is agonist. Okay, because we are pro this, anti this, antagonist. Ketamine, all this lah. Okay, now where does this come in? Sometimes in the YWA, they say fundamentalists. Seen so many of them, but they are very intelligent, Say if I give you this oil, this agent, 1 wow. How do you know How can you know that this can give anaesthetic loss of consciousness property or not based on Meyer-Overton? How would you go? If I give you this sample, extract from somewhere, give to you this liquid. How will you know it is a good anesthetic or not anesthetic? How will you know based on Meyer-Overton? How will you know? How will you know? How will you know? How will you know? This is why. How will you know? So how will you do it? Let's say why. How will you do? How will you do, man? Really came out in the why, no? See, you're sure getting great. But later I tell you the answer is so straightforward. How will you know? It's something called a correlation. Yeah. No. It's the Meyer-Overton correlation. It's a correlation. Yeah, Meyer-Overton correlation. It's a correlation. So what you do, you say like that. See, this is oil gas partition coefficient. This is your anesthetic partial pressure, your MAC. So oil gas partition coefficient in this log also. So that means it will depends on where you do the experiment, where if the oil that I give to you is here, what does it mean? Not potent. It's nothing to dissolve. The Meyer-Overton is a potency one. That means not potent. If it's here, dissolve it, it is potent. Because Meyer-Overton talk about dissolving into the lipid membrane only. Dissolve. That means the agent, it can dissolve in your fat like that. If it's very soluble, see, fat, it's very potent. So that means if your agent is, so you just draw this to the examiner, I guess, then the MAC So if the compound they give me, if happens to get dissolve it happen to be here on animals then this one will be very potent. Not potent, it's a potent because it's a correlation. Because the more fat soluble it is, see the coefficient, it is the MAC. Partial pressure, this is the MAC. Because low MAC is, high MAC is lousy. Like nitrous oxide is 104, low MAC. So it depends on where the drug is dissolved, oil is dissolved. Now, I just put these three. See here, oil gas. Look at here. Can you see here? What is this? This is in atmosphere, correct? This is MAC. Is that correct? This is potency. They are the same. So that means when you read on the y-axis, you can put MAC, potency, anesthetic, partial pressure. They are the same. MAC is potency. MAC is partial pressure also. You understand not? MAC is partial pressure. MAC can be converted to millimeters of mercury. So that means, don't get confused. See the MAC, direct related to lipid solubility. See, later we will get more here. We'll come back to here again. Because when we talk about MAC, see when you down, what is MAC of CO? Or 2 correct? So you put 2. You see your thing there, you down 2. Correct? What is that 2? Percentage. It's a percentage. Percentage of what? See, when down 2, you realize or not? When down 2, what does it mean? It's a concentration, yes. It's a percentage, it's concentration. Can it be converted to millimeters of mercury? Because actually, when you talk about MEC, you're talking about the brain. Brain. So you want to know how much partial pressure of the agent is in the brain. Correct or not? But we're talking here 2 only. So let's say 2, how much you think is the partial pressure here? What do you think? This MEC is percentage of 1 atmosphere. Right? So it's 2 over 100 times 760. That will give you the millimeters of mercury. You agree or not? So it's, if I'm because sometimes you put 2. See, that's why the people ask you. You put 2. Hey, what is? That's why I put it here. It can be partial pressure. This definition of MEC. 1 atmosphere. So 2 divided by 100 times 750, how much? 15. So that means 15. That means, in fact, actually, if we want, we can recalibrate. Instead of 2, be 15 milliliters of mercury in the brain. You understand now? So sometimes they will ask you, what does it mean? You say 2% of 1 atmosphere. You convert to partial pressure. You found or not? Later we go through the definition. Okay, volatile agent. See, can be pro, anti this. Okay lah. You look the gases are mainly this is the gas. Gases are mainly NMDA. Now, sometimes we ask people what is the saturated vapor pressure, volume pressure. People go like a parrot. But later when we ask them what's the significance, they are in trouble. See, look at this. Look at this. You look at the boiling point. Look at everybody. Look at that. Boiling point, so low. What is our room temperature? Noti. 27, die, man. You know you can put 27. Can. When you surgeon operate too long. You on the temperature is they sweat. Then they cut faster. Standard we put around 20 20. So if at this so people ask you, okay, but get boiling point. Yes, you say 23.5, pop 23.5. Wow, then next question we ask you, what's the significance? What's the significance? You look at that. At 23.5, it boils. And your saturated vapor pressure is 89. This is in kilopascal. If it's in not 669 is not the non-milliliters of mercury, So that means you will boil. All of us die in OT, or the patient will be. So that's because of that you need a special vaporizer. I'll tell you how they do that special vaporizer. See, everybody, this tell you that everybody you can use the tag vaporizer. This one cannot. This is the reason why we need a special vaporizer. Now, blood gas. Look at this. The rest all, see, 14, 14, 24, quite high compared to gas 0.45, 0.7 low. That means we love this because it's fast. Fast onset, fast offset. Okay lah. MAC, see the MAC. See, 6.6, not so good lah. CO2. That means this is very potent. This is not as potent but compared to others. See, nitrous oxide 105 useless. Why is it 105 useless? It's not potent, and not potent also because another thing also danger. cannot give pure nitrous oxide. So that means when you have this, you got a lot of space to give your oxygen. See, low because we can add oxygen. Yeah. So it means I brought this slide. Because some students they can, I don't know how, man, they can memorize all the number. But then when we ask them what's the significance of this, boom, mati. You understand what? Huh? So you don't have to remember. If you need to just remember the common one, right? Common one. Look at this, see? Oh God, 667. Huh? 667 boys. Boys. So that's why you need a special vaporizer. So that means if they ask you what you put, what happens if you put diflouromethoxy in a normal tank? The normal tank will boil. And then the amount, you know what happens? You will boil, and then you get this into the brain. Okay lah. Because if we go at zero, that's we go at that's what is the max? They're here. I guess 6.6 divided by 100 times 760. How much is that? Wow, but you give this one. Huh? Perfect boy already. See? So that's the danger of it. Now, blood gas. Sometimes people ask you, the blood gas. Then we say, what do you mean by blood gas? Blood gas coefficient of, let's say, what does it mean? Wow, so people sound good, man. What do you mean by blood gas? At equilibrium, you take the concentration of the gas in blood, divide by in where? Equivalent in alveoli. See, because sometimes people like to throw words. You understand? They throw blood gas, this. Then I say, can you actually tell me what do you mean by blood gas? What do you mean by blood gas? They say that at equilibrium, the partial pressure of the gas in this one phase over the other give you that number. And then if the number is small, good. Why is a number small good and number big no good? We talk about blood gas. We're talking about partial pressure, the tension, the partial pressure, the tension. That means we are talking about plasma level. Tension of the gas in the plasma, not the red blood cell. Structure activity, you read lah. Okay, certain things. Okay. If you have this difluoro, this one will produce carbon monoxide. You have this, all fluoride, trifluoroacetic acid, trifluoro. This one is associated with all those liver toxicity type, the heptane. So this one, to produce carbon monoxide, essentially you must have this normal usage. So it's sivorine. Look at sivorine. Sivorine. There. Sivorine don't have difluoro. So technically, sivorine has got no carbon monoxide in normal usage. But if it's overheated, temperature more than 80, then it can break and cause carbon monoxide. So therefore, it's normal. So to produce carbon monoxide, you must have this structure. MCQ, how to remember? Carbon monoxide. What happened to carbon monoxide when you take carbon monoxide? You die. Correct or not? How do you spell die? Desflurane, isoflurane, ethane. Because carbon monoxide can kill. MCQ, you have to think fast. You found not? So that's how I. Okay,